So for our next example, we're going to either evaluate the integral from 1 to infinity of 1 over root x, or show that it diverges. Based on the last example, you might have looked at that and said, oh, I see how it works. Functions of this shape, they have, even though we can extend them all the way out to infinity, that means that this area surely must be a finite number, and we just have to find it. But, like I said, the answer is going to be that sometimes it is finite and sometimes it's not. So let's see what happens if we try to integrate a different function with this shape. And you can use Desmos or something like that, or a graphing calculator, to verify that this is a good representation of 1 over root x that I've drawn here. So let's set this up again. We know that the integral from 1 to infinity of dx over root x is going to equal the limit as as b approaches infinity. The integral from 1 to b of, I'll rewrite this as x to the negative 1/2 dx. That's a better representation of 1 over root x for the purpose of applying the power rule for integrals. So this is going to equal the limit as b approaches infinity of x to the 1/2 over 1/2 from 1 to b. So that equals limit as b approaches infinity of, this looks like it's going to be 2 divided by 1/2 is the same as multiplying by 2, so that's going to be 2 square root of x from 1 to b. That's going to be the limit as b approaches infinity of 2 root b minus 2 root 1. So that equals the limit as b approaches infinity of 2 root b minus 2. Well, if we take the square root of b as b is approaching infinity, we just get infinity. So this is going to equal infinity minus 2, and infinity minus 2 is still infinity. So the limit comes out to infinity. That means that therefore, I think you've seen me use this symbol before, the 3 dots in a triangle means therefore in mathematics. Therefore, the limit does not exist, so the integral from 1 to infinity of dx over root x diverges.